Hello and good morning, CTS110 Section 840 students for the Spring 2016 semester at Anne Arundel Community College. This is the CompTIA Networking Plus course, and this morning's video tutorial is going to be on our Unit 6 worksheet, where we're going to be focusing here on IP subnetting, and specifically we're going to be doing a subnetting exercise with Class C addresses. So let's go ahead and dive in here. You can see that from our lecture discussions, the byte values, and remember when we're subnetting, when you're looking at those values that sit in the 4 bytes or the 4 octets, each of those 8 octets, or I'm sorry, each of those 8 bits inside the octet will have a specific value assigned. And if we're going from right to left, or from the low order bits to the high order bits, what we see is we have a value of 1, and then 2, 4, 8, 16, 32, 64, and 128. Now, remember that the subnet mask is the part of the equation here when we're talking about subnetting that tells us which bits are network ones and which are hosts. So if we look down here, when we talk about a Class A address, the default subnet mask, it is a /8. And so you can see the first 8 bits, or the first octet here, or the first byte, all of our values are 1s, because again, those values are representing, the 1 values are representing the network portion of the address. And then we have 2 to the 24, which is 16.7 million. So 16.7 million host addresses. And here is the default subnet mask in dotted decimal. The same goes for the Class B. It's a /16. So the first 16 bits, or the first 2 bytes, or the first 2 octets, remember byte and octet are synonymous, that these are going to represent the network portion of the address, which means we have 2 to the 16, which I believe is 65,535 host addresses, right? And again, in dotted decimal notation, it would be 255.255, because again, all the bit value positions are on here in the first octet as well as the second octet, so we get that maximum value of 255, and then we have 0 and 0, again, this being the host portion of the address. The Class C is a /24. So again, the first 24 bits in the IP address are all, or I'm sorry, in the subnet mask are all going to be 1s in the binary form, and then it would translate to this value, 255.255.255.0, in dotted decimal notation. Now again, these are classful because they are, these are classful, I believe it only has one L. These are classful subnet masks because they are the default masks that represent that class of address. So again, Class A, the default subnet mask, which would be classful, is a /8, a /16 for Class B, a /24 for Class C. Because when we go to subnet, what we're saying is we want to go ahead and right size or borrow bits from the host portion of the address and turn those into network or subnet bits. And let's scroll down here and we'll take a look. You can see here that that's what we're talking about, is when we're borrowing bits. So here is my default subnet mask, right? So I've got 24 network bits for a Class C, and we have 8 host bits. Now, if I wanted to borrow some of these host bits, you can see we've converted these host bits here into 1s. So I end up with how many total bits now representing the network portion? Exactly, 24 plus 3 would be a /27, and in dotted decimal notation that would be 255.255.255. Now we need to take 128 plus 64 is 192 plus 32 is 224. And so that CIDR notation is equivalent to this subnet mask in dotted decimal notation. And our block size, again, is going to be that rightmost 1 bit here. So 128, 64, 32. So our block size is equal to 32. And we only have 5 host bits left. So with these 5 host bits, it's very easy for us to figure out how many total IPs we'll have, and that's going to be 2 to the 5, and that would be 32. But how many usable IPs do we have? It's 2 to the 5 minus 2. So each of the subnets is going to have 30 usable IP addresses. And again, what we're saying here is we didn't need to have 254 usable addresses, which is what we would have had here, right? With 2 to the 8 minus 2, we end up with 254. We didn't need 254 addresses. We wanted to make smaller, more appropriately sized networks to maybe more accurately reflect the number of hosts that we are going to have. And so we subnet. We create smaller networks from a larger network. Okay, and again, if it's think of it like this. This is a good analogy. Is where if you have a pie, right? You're probably not going to sit and eat the entire pie because that's too much pie for you to eat. So maybe you cut it in half, or you divide it into quarters. Again, you cut smaller pieces out of that larger pie because that's probably all you're going to be able to eat. And it's the same thing here. We don't want to waste, bake an entire pie only to eat 1/4, or I should say 1/8 of the pie, or a smaller portion of the pie, and then throw the rest of the pie away for it's wasted. So what we do is we subnet. We take that pie and we carve it into more appropriately sized pieces that we are going to be able to fully utilize. So let's go ahead and slide down a little bit here. So, and here's a great chart which talks about the interesting octet, right? Or which octet are we changing? Well, we're talking from a perspective of this example here, and with a class C, as we start to borrow from the 4th octet, right? That last octet, and you can see as we move over from left to right, we are getting different subnet mask values. Now remember that the subnet mask bits that we're borrowing, we have to go from left to right. We can't simply step in here and say, oh, I'm going to use that bit and this bit and maybe that bit right there. You can't sort of jump around. When you're subnetting, it has to start from the left-hand side and then you work your way down to the right. And so we kind of talked about this in lecture. The values that you will see would be, if we're talking about this Class C setup here, would be 0, and then 128, and then 192, 224, 240, 248, and 252. And it's going to have to be, in this scenario that we're looking at right here, it's going to have to be one of these 7 values. 1, 2, 3, 4, 5, 6, 7. Yeah, one of these 7 values here. And so with subnetting, it's not too difficult to sort of memorize or become so familiar with these values that when you are doing the subnetting, this becomes sort of the easy portion, is coming up with that dotted decimal value for the 4th octet when we're talking about Class C addresses, just knowing that you're simply adding and moving from left to right. And so this answers the question. Remember that the borrowed bits tell you how many subnets you're going to get, because again, we borrow 1 bit, so we get 2 subnets. We borrow 2 bits, we get 4, and then 8, and then 16. And so this is how many subnetworks I'm creating. So if your boss came to you and said, hey, we need at least 60 subnets, and each subnet needs to be able to provide 2 usable host IPs, then this would be the subnet that you're looking for, right? Now, it's interesting when we get into the Class B addresses, what you'll see is, well, what happens if my boss comes to me and says, hey, I need at least 60 subnets, right? So I need at least 60 subnets, but I need each of those subnets to be able to handle at least 200 hosts. And so this is the use case where when we're talking about, oh, I need at least 60 subnets and they each need to be able to contain 200 hosts, where this is no longer the solution. And so then we need to look into our subnetting of a Class B address in order to achieve what we're talking about. All right, so let's go ahead and squeegee that off. Now the same goes for, we're talking about the number of subnets, the number of valid hosts. Again, it's 2 raised to the power of the number of host bits that remain after we borrow those network bits. And so the value goes up, but remember, we subtract 2, and the 2 that we're subtracting, one is for the broadcast address, and the other is for the network ID. And so again, this is the default for the Class C, where we get 254 hosts, and then it simply scales down, right? Based off the number of host bits that remain. So now let's jump in here on this final page, and this is going to be our opportunity here to show our mastery of the topic. And let me shrink down. Let's see, see if we can get this all on. That's what I'm looking for right there. All right, we're going to see if we can get this all on one page here. All right, there we go. So now your turn to complete the questions. All right, so let's work through this scenario here in terms of how do we subnet. So here is the Class C IP 200.10.13.0, and we're simply saying that by default it's a /24. So the CIDR notation of /24 converts into this notation here, which is a binary representation of the CIDR, or the classless interdomain routing notation that we have above. And so each of the first 24 bits going from left to right is going to be a 1, because those represent the network portion of the address. Here is our host portion of the address, right? So we've got 8 bits, so by default we have 2 to the 8 minus 2, and we saw this on the previous sheet, so 254 usable host IP addresses. Now, your company has 4 departments. Each department needs to have their own subnet. So create 4 subnets. Now, the key number is number 4 right there, and this should be a dead giveaway. And if we know our powers of 2, as soon as I see this, I should be able to say to myself, okay, we have 4 departments, we're going to need a subnet for each. How many bits would I have to borrow to get to 4? Well, that's easy, right? It's 2 to the 2 equals 4. So, and that's a terrible 4, sorry about that. 2 to the 2 equals 4. So all I need to do is borrow 2 of the host bits, right? Remember, these 2 bits right here, the first 2 bits are going to be borrowed as network bits. And so we also have our block size, and this is kind of, what I was impressing upon you in class and lecture Tuesday night was finding the block size out. Once you get that, it's pretty much game over. So remember, the block size is simply the rightmost value where we've borrowed a host bit and turned it into a network bit. The other way that you could figure this out that we talked about was simply take 2 to the number of host bits. So 2 to the 6 is also 64. So there's 2 ways that we could do it. If we knew the number of host bits that remain, or if we just simply look at the binary representation of the subnet mask, then all we would need to do is look at the rightmost 1 bit and say to ourselves, what bit position value does that bit carry? Well, that carries 64. Now, again, once you get the block size, it's pretty simple from there. So, I mean, even before we get down here, all I have to do is say, okay, it would be .0, .64, .128, and .192. And remember, if you add 64 to 192, you get 256. We know that that's too high. So then all I need to do is back myself into what are my 4 networks. Remember, the broadcast address is going to be one less than the next network ID. And so here are my net IDs. And .63, I'll draw the line down here. And these are my broadcast addresses. So right there with the block size, not only by only knowing the block size, not only am I able to tell you what the network ID is going to be or the subnet ID is going to be for each of the 4 networks, I'm able to tell you what the broadcast addresses are. And by virtue of that fact, I can tell you what 62 IP addresses are going to fall in the usable range here. And remember that the network ID is always an even number, and the broadcast address is always an odd number. So you can see here 63, 127, 191, 255. And so here are the 62 usable or assignable, the IPs that we're going to be assigning to the hosts in these networks. And we arrived at this answer here based solely off of one value, and that is the block size value. So new subnet mask creates 4 subnets, right? Because 2 to the 2 equals 4. Each subnet has blank possible hosts. Well, 2 to the 6 minus 2 is going to be 62. 2 to the 6 is 64 minus 2, so we're going to have 62 possible hosts. And then what do we have here? Fill in all subnets first, and then all broadcasts. Okay, so they're just basically asking us, so the subnet address here, so our first subnet would be 200.10.13. And this is our second network ID, so it just goes up by 64. And then again, 128. And then 192. So the valid host IP addresses are .1 to .62, .65 to .126, .129 to .190 to 190, .193 to .254, and then our broadcast IP addresses, we know that this is .63, .127, .191, and .255. And so that's it for being able to figure these things out. And again, it's not very difficult once you figure out the block size. You've got all the information you need to complete any subnetting problem that's presented to you. And as we saw, and I'm going to be putting a supplemental video together to talk about Class B subnetting, or subnetting Class B addresses, I should say, where we're dealing with the 3rd octet all the way up to and through the 4th octet, that this still applies. That if you can just look at the rightmost subnet bit to get this value, you're going to be able to solve any subnetting problem that you're presented with. All right, well, this wraps up this quick tutorial and review of worksheet number 6. Have a great weekend. Enjoy the rest of your weekend, I should say, and I will see you all on Tuesday evening.